Hello everyone, welcome back to my channel. In this video, we'll talk about a study that was done in 2019 to compare 7 deep learning models for security event detection. For those of you who are interested in reading the details of the study, I have linked it in the description below. The study was conducted by several PhDs in the field of cybersecurity and artificial intelligence. The deep learning methods were compared using 2 public data sets, the CSE-CIC IDS 2018 dataset and the bot IoT dataset. The performance indicators that were measured were false alarm rate, accuracy, and detection rate. This research paper provides a survey and comparative study of deep learning approaches for intrusion detection in cybersecurity. It focuses on reviewing intrusion detection systems based on deep learning techniques and also emphasizes the importance of data sets in intrusion detection. The authors describe 35 well-known cybersecurity data sets, and then they categorize those into 7 types, such as network traffic-based, electrical network-based, internet traffic-based, etc. And although they do that in their paper, they only test against those 2 that I had mentioned before. Most importantly, the paper analyzes 7 deep learning models, including recurrent neural networks, deep neural networks, restricted Boltzmann machines, deep belief networks, convolutional neural networks, deep Boltzmann machines, and deep autoencoders. The performance of these models is studied in 2 classification categories, binary and multi-class, using 2 real traffic data sets, the 2 that I had mentioned before, and then they evaluate the efficiency of different methods. The paper highlights the relevance of machine learning and deep learning in the field of cybersecurity, particularly intrusion detection. So the first one is recurrent neural networks, RNN. These models process sequential data by maintaining internal memory and can capture dependencies. So some of the popular applications for RNN are language modeling and text generation, machine translation for sequence to sequence models, like learning the relationship between input and output sequences, sentiment analysis to classify the sentiment expressed in a given text. They can learn to recognize positive, negative, or neutral sentiment by processing sequences of words or characters. And then we have speech recognition, time series analysis, handwriting recognition, and video analysis. And then with deep neural networks, also called DNN, multi-layer neural networks with several hidden layers for learning complex representations. They can do image classification, object detection and localization, natural language processing, speech recognition, recommendation systems, fraud detection for things like banking, insurance, and e-commerce, autonomous vehicles, and medical diagnoses. And then we have the restricted Boltzmann machines, or RBM. These are generative stochastic artificial neural networks that are used for unsupervised learning. They do things like collaborative filtering and user recommendations from data, unsupervised feature learning for discovering features within a data set, pre-training for deep learning, dimensionality reduction, deep belief networks, which have been used in generative modeling, image denoising, and natural language processing. And then we have deep belief networks. These are composed of multiple layers of latent variables used for both generative and discriminative tasks. They can do image recognition, feature learning, anomaly detection, speech recognition, collaborative filtering, time series analysis, natural language processing. And then we have convolutional neural networks, or CNN. They are specialized for processing grid-like data such as images, through convolution and pooling layers, image classification, object detection, image segmentation, face recognition, artistic style transfer from one image to another, video analysis, medical imaging, autonomous vehicles, and natural language processing, to name a few. And then the next one is deep Boltzmann machines, or DBM. These are generative models with multiple layers of latent variables, often used in unsupervised learning. The main difference here between deep Boltzmann machines, DBM, and restricted Boltzmann machines, RBM, lies in the architecture and training algorithms. So both RBM and DBM are generative models, but their generative modeling capabilities differ. The RBM can generate samples by performing alternating Gibbs sampling between the visible and hidden units. DBMs with their deeper architecture can generate samples by performing Gibbs sampling between layers, allowing for the generation of more complex and structured data. And then DBMs, while conceptually powerful, have seen limited practical application due to the computational challenges associated with training them. But that might change, especially with the advancement of breakthroughs in quantum computing. And then lastly, we have deep autoencoders. These are neural networks used for unsupervised learning by reconstructing input data from reduced dimensions. They can be used for things like generative modeling, unsupervised clustering, text generation and sentiment analysis, and unsupervised clustering of similar data instances. Next, we're going to look at what the study found. Which of these 7 models were performing better in intrusion detections of the public data sets that were used in the study? The study highlighted 4 models that did particularly well. One of them was RNN, so that was the recurrent neural networks. The RNN performed exceptionally well in detecting various attack types, including brute force cross-site scripting, brute force web, and several denial of service attacks. The next one the study called out was deep neural networks, the DNN. This model achieved the highest true negative rate among deep discriminative models, indicating its effectiveness in correctly identifying benign cases. And it became a strong choice for overall intrusion detection. The next one was convolutional neural networks, CNN. CNN demonstrated the highest detection rate for several attack types, such as distributed denial of service attacks and botnet. It was a robust choice for detecting attacks that exhibit distinct patterns or features. The next one was deep autoencoders. Among generative unsupervised models, deep autoencoders exhibit the highest detection rate for specific attack types, including brute force web, DOS attacks, and infiltration. They offer strong capabilities for identifying those types of attacks. And deep autoencoders can be generative or discriminative. That model can be applied in either way. So when it comes to sniffing out sneaky network intrusions, discriminative models take the lead over generative models. These smart models focus on learning the differences between various types of data. They're all about creating the clear-cut line that separates normal network behavior from suspicious or downright malicious activities. Picture this. Network intrusion detection is like having a superhero nose for sniffing out weird network patterns that might indicate a security breach. Discriminative models like support vector machines, random forests, or deep neural networks are the go-to heroes in classifying network traffic as either good or bad. In this particular study, it was RNN, DNN, CNN, and deep autoencoders. They use fancy features extracted from network packets or flow data to make their decisions. Here's the scoop. These models learn the ropes by using labeled training data. They study examples that are flagged as either normal or malicious. By tweaking their parameters based on the labeled data, they become expert classifiers, nailing the task of identifying incoming network traffic as either harmless or malicious. Now, on the other side of the coin, we have generative models like generative adversarial networks or GANs or variational autoencoders, which they classify as VAEs. And these models have a different agenda. They focus on understanding the underlying probability distribution of the training data, while they're pretty cool at generating new data samples that resemble the training data, they don't shine as bright when it comes to intrusion detection. That's because their real talent lies in creating rather than classifying. But here's the thing, network intrusion detection is constantly evolving field. Researchers are always on the lookout for fresh approaches and new tricks. So who knows, in the future, we might see exciting advancements in generative models or even some hybrid approaches. These could bring new insights and jazz up the effectiveness of intrusion detection systems. So this study really did 5 things. They examined models and learning methods, deep learning methods that were both discriminative and generative to determine which models performed best among the 7 that they studied. And then they did data set classification. They did cover in their study or their research 35 well-known data sets. They classified them in the paper. In their research paper, they used 2 data sets to actually do the research against. And then number 3 is deep learning approaches. So they analyzed 7 different deep learning approaches divided into 2 categories. The first category focused on discriminative models, including the RNN and the DNN and the CNN. The second category dealt with generative unsupervised models, including the deep autoencoders, the restricted Boltzmann machines, the deep Boltzmann machines, and the deep belief networks. One of those performed well. The other 3, I believe, were the discriminative models. And then they evaluated the performance. They assessed the performance of the deep learning model using 2 real traffic data sets. That was the CSE CIC IDS 2018 data set and the bot IoT data set. These data sets represented actual network activities and helped them understand how well the models could detect intrusions. And then the comparison with traditional machine learning. They did compare these deep learning models with traditional older style machine learning methods. They found that the deep learning methods way outperformed the traditional machine learning methods. They compared the performance of deep learning approaches with 4 traditional machine learning methods, which were the naive Bayes, the artificial neural network, the support vector machine, and the random forests. And that allowed them to understand the relative strength and weakness of deep learning in intrusion detection. Friends, I hope you enjoyed this video. Stay curious.